Hi everyone, I'm Dr. Lee. This lecture helps you understand the uniqueness of geospatial data in GIS. From our textbook, it is chapter 5. Let's begin. For someone who is fairly new to geographic information systems, the most interesting question is how GIS represents or take the real world items into computers. For example, how would customers be stored in computer files and shown on the monitor screen? How about streets or rivers and streams? How about houses, buildings, parcels, and so on? How would you visualize some terrain data such as flood risk or elevation? These are really interesting questions. Of course, you can create a table for such information: population size, average age, average grocery spending per person or household, property values, types of tree species, and so on. Even though you have found and downloaded data tables full of the information you are looking for, you still need to find a way to incorporate a special context for these tables. Of course, GIS fortunately enables to link those non-spatial data stored in the table, to a set of locations, as well as perform several useful operations such as spatial analysis and visualization. Let's dig deeper how to model the real world so it can be effectively translated into a computer file. So here is my example. Can you recognize this? These are some examples of items or objects from Minecraft, a video game. Some are awfully boxy or pixelated, but we can recognize what each entity represents. Of course, my 5-year-old son would argue he would not look like the boy in green shirts and blue pants at all. When you decide which way to capture the real-world object into geographic information systems, you should look at the nature of the object themselves. For instance, can you take its shape as realistic as possible, or it is hard to tell where the object begins and ends, so it is challenging to trace the boundaries. In GIS world, there are two conceptual views of geographic phenomena or objects. Depending on this conceptual view, two types of GIS data models are developed: vector and raster. I will explain this in detail soon. There are two conceptual views of geographic phenomena: discrete object view and continuous field view. If the phenomenon occurs at distinctive locations and occurs not somewhere else, then we can take the pattern of the phenomenon using discrete, distinctive object. If the phenomenon occurs almost everywhere and hard to tell where it begins and ends, then we can take it as continuous pattern. Let's look at more closely. First, discrete object view conceptualizes the world with a series of separate objects that have fixed locations, fixed start and end points, fixed boundaries, and so on. These discrete objects are developed into vector objects of points, lines, and polygons. Points are zero-dimensional, while lines or polylines are one-dimensional with a length. Polygons are two-dimensional vector objects that have an area such as an square foot or a square mile. This vector object consists of a vector data model that represents the spatial data. Here are more examples of vector object. Of course, depending on how you conceptualize the object, the same object can take a form of point or polygon, just as in the image. In other words, Candelaria hole can be stored as a point or polygon that has an actual area. How can you develop the vector model? Using a scanned map image or digital imagery of aerial photo or satellite imagery, you can sketch or trace the object. This process is called digitizing. For those who have done the lab on digitizing, you probably know how this works. This process is also frequently utilized to update or edit the existing GIS files. Regardless of the number of hours and amount of efforts you put in digitizing, it is likely impossible or unfeasible to sketch every single detail in the image as labor-intensive it is already. One of the most important nature of the vector model is topology. Don't get confused with topography, which refers to a terrain relief. Here, topology means geometric characteristics among vector objects. In other words, how they are related to each other, and this is not necessarily due to their XY coordinate. Topology, therefore, purely represents the special relationships among the vector objects. Three main characteristics can be mentioned: adjacency, connectivity, and containment, and each represents different types of special relationships. Adjacency represents the boundaries and the boundary relationship. Connectivity and containment refers to the position of one polygon compared to other polygon. These characteristics have become quite important, particularly when you are to make a subset of selection using one of these relationships, or analyze the relationship or the result to stem from these relationships. In ArcMap, when you make a selection, you can choose a geographic object using select by location function, which returns the result based on the topology. In next segment, we'll explore the other GIS model, that is raster model. See you then.